Welcome, students, to our first attempt at writing down our notes from a video lesson. Today's topic is we're talking about fractions and decimals, and our essential question on this lesson is how do we convert decimals into fractions or vice versa? Remember, that just means backwards, to compare them. And you're going to want to pause right here while you copy down what you see. Leave those two examples, 4/5 and 3 1/4 blank for now, but copy everything else that you see. Okay, welcome back. If you forgot to pause, you want to pause right now and copy down what you see. Okay, so welcome back again. Okay, so we're converting fractions to decimals first, and we're dividing the numerator by the denominator. And if you forgot, I like to remember that I keep my demons down, and that's how I know my denominator is the bottom number. And when we are setting up our division, the denominator goes on the outside, and the numerator goes on the inside. And we're going to have a fraction form, so we want to get our decimal points set up here. 11 goes into 2. Oh wait, before I actually do this division, I want to remind myself that my answer is going to be negative, because when we convert fractions into decimals, it doesn't change its signs. Since our fraction began negative, our decimal's also going to be negative. Okay, so back to our division. 11 goes into 2 0 times. We have to add 0 behind the 20. That goes into it 1 time. We got to add another 0 and continue. How many times does 11 go into 90? Aha, that's right. If you said 8, that is the correct answer. And we don't actually know it's repeating just yet. We have to have proof it's repeating, so we want to keep on going. And when we deal with a repeating decimal, you normally want to see it repeat at least 3 times. That's how you know the pattern has happened. But since this is a 2-digit repeating example, we'll just show it twice for now. And we have proof it's going to repeat. We have that 2 showing up 3 times. So we have to recognize that when we write this answer, this is our work for the problem. But not all of this has to be shown in our answer. We are going to write the 0.18 and then use the repeating bar for the 1 and the 8, because the 1 and the 8 both repeat. So now copy down example 1 here. Great, now we're going to do that problem. The 5 goes on the outside, and the 4 goes on the inside. We need that decimal point again, because we are going to create one. 0 goes up there, 5 goes into 40, 8 times. And this one has terminated, so our answer is 0.8. For mixed numbers, how I set up mixed numbers is the number in front will always be in front of the decimal point. So now all we actually have to do is divide 4 into 1. And I know there's other ways you can do this, but this does work the easiest way. Goes into 10 twice. Scroll that down a little bit. Got to add another 0 because it has not terminated yet. Bring that 0 down. 4 goes into 25 times. And now that is terminated, so our answer is 3.25. Let's moving on. If you could, I'm going to actually show you this page, and you want to pause here so you can copy it down. Okay, welcome back. So now we're converting decimals back into fractions, and this is all based on the place value's name. So we have to determine the place value name in the denominator. And it's not all these place values here. We're only going to care about the smallest place value. So just like on our mixed number example from the previous page, this 7 here is going to stay out in the front of our answer box. So now what we have to actually do is start looking at this second place value. So if you remember from our lessons or previous lessons, there is no such thing as the 1th place. So this first place value is the 10th. The second place value is the hundredths. So we're going to have to put a 100 in our denominator. And we put the numbers in the decimal places on the top. Now we can't say the answer is 7 and 2 over 100ths because all fractions need to be put in simplest form first. So we have to divide the top and the bottom by 2 to simplify it. And now we have 7 and 1/50th. So again, all of this creating a decimal into a fraction is based off the smallest place value's name. And in this example, the smallest place value was called the hundredths place. So we placed a 100 in the denominator. And you're going to want to pause one more time here to copy down this problem. That's actually a lie. We're going to pause again in the future. Okay, welcome back. So in order to compare fractions to decimals, we either have to convert both numbers into fractions, or we have to convert both numbers into decimals. For this example, since this is the thousandths place, and this would create a large fraction, we're going to choose to convert 7/9 into a decimal. We have a strong indicator here. This is repeating, but again, we should show this repeat 3 times before we have proof it's repeating. And again, this is just another example of how our work does not always look like our final answer. So we know that the 7 is repeating. So 7/9 is the same as writing a different decimal. We could actually write 0.7 repeating compared to the decimal we originally had, 0.756. As we're looking at this, you can now see that the 7 would go on forever in the blue part here. And this decimal point of 5 changes. So which one's bigger, 5 or 7? You're right, the 7 is bigger. So that is why we use that greater than symbol in there. And we do always want to realize that should go in the final answer as well as in the original number box. So 7/9 is greater than 0.756. So now we have 2 more examples, and I'm going to show you both examples. But just like in class, please remember to leave some space here so we can do the problem. Don't write these right on top of each other. So here are the next 2 pages for you to copy down, and we'll pause here while you do that. Okay, great. Welcome back. So now that you wrote the problem down, the next phase is us to interact with our word problem. We're going to start circling words we care about. So this problem is all about teenage boys, and we're going to circle the 2,700 calories per day. And then we have 360 calories that should be coming from milk. Okay, so we have this total calories of 2,700 and this part calorie of 360 calories. Now the problem wants us to make sure to remind us we're going to go to the nearest hundredth if necessary. And from left to right, it says part of a teenager bottle total calorie there. So remember, we've learned that this is all done from left to right. So it would be part divided by the total. And I wrote it that way to show the left to right, but that is the same as writing part over total, which makes us realize we actually are creating the fraction. So now we just put our part number on the top, which was 360, and we substitute our total number on the bottom, which is 2,700. And then we have to simplify this fraction. And what number goes into there? We can divide them both by 10 to get rid of these zeros. Now we're looking at 36 and 270. The way I help my brain simplify is I have looked at this and realized 36 and 27 are multiples of 9. That means that this whole number is multiples of 9 likely, so let's try that. And again, this is a point where we could be using guess and check. So 36 divided by 9 gets us down to 4. And 270 divided by 9 gets us not down to 3, but 30. Those are still even, so we need to keep on going. But this is a good model that you don't stop on your first hypothesis. Sometimes we keep on going. And we know the answer is 2 over 15. Oh, wait, that's a fraction, and it wants a decimal. But since we simplified it, this will make the math as easy as possible. Look at that 5 repeat. Again, we want to have a little bit farther to know that this is for sure going to repeat. Oh, it's not repeating. Oh, it only repeated the last digit there. Is it up? But that digit's going to keep on repeating. But do I have to go any further if the directions said round to the nearest hundredth? You're right, I don't need to. So since I need only to the hundredths, I'm looking at my 3 here, and that means I'm going to keep the 3 in front the same. So our answer for this problem is 0.13 calories should come from milk in your total calorie diet for a teenage boy. I'm going to have you work on that last problem with me in class. That's how I know you'll watch the video. Make sure you have it copied down, and we're going to do that last problem together, which is just the same as what we did here, but it's bringing it into a compare and contrast problem. I hope this worked out. Let me know if you have any problems with this video lecture tomorrow in class, and if not, thank you so much.